Hello everyone. From today we are going to discuss first order differential equation, and in this lecture we are going to discuss how to solve exact differential equation. In the previous lecture I have already discussed what is ordinary differential equation, what is first order differential equation, what is order, what is degree, and most important theorem I have already covered in the previous lecture, that is necessary and sufficient condition for exact differential equation and some examples on exact differential equation. If you have not seen that lecture, then link is given in the description box. You can watch that video so you will get a clear idea what is the exact differential equation and what is a linear differential equation. In this lecture, we are going to discuss examples on exact differential equation. Here, suppose we have given the equation in the form of m, which is a function of xy dx plus n, function of xy dy is equals to 0. This equation is called exact differential equation. Exact differential equation, but when if it satisfied the condition, that is del m by del y is equals to del n by del x. So this is the condition for exact if differential equation in this form, coefficient of dx we have to differentiate partially with respect to y, and coefficient of dy differentiate partially with respect to x. And if they are equal, then we can say equation 1 is exact differential equation. Now if our differential equation is exact, then we can find its solution. So the solution of our differential equation is integration of m dx plus integration of n dy is equals to integrating constant c. Here m y we have to take as a constant. From this equation 1 we get the value of m, but at the time of integrating this m we have to keep y as a constant, and in the n we have to take the terms of n not contain not containing x. This is the solution of equation 1, that is exact differential equation solution. And here we have to take integration of m keeping y as a constant plus integration of n. From this n we have to take the term which does not contain x is equals to integrating constant c. So this is the solution of our given equation 1. But this is the solution if our differential equation is exact. So let's say the example. For example, solve the equation solve the equation e raised to the power y dx plus x e raised to the power y plus 2y dy is equals to 0. Now see here, if we compare the given differential equation with mdx plus ndy, so here our given differential equation is e raised to the power y dx plus x e raised to the power y plus 2y dy is equals to 0. If we compare this equation with mdx plus ndy equals to 0, then we will get the value of m and n. So coefficient of dx, that is called a m. So m is equals to, so after comparison of this equation with this general form, so we will get m, that is m is equals to e raised to the power y, and n is equals to x e raised to the power y plus 2y. Now, is it a equation is exact? So for that, we have to differentiate this m. M is a coefficient of dx. So m is a coefficient of dx. We have to differentiate this m partially with respect to y. If it is a coefficient of dx, then that term we have to differentiate partially with respect to y. So after differentiating this m with respect to y, we will get the derivative of e is again it is a e raised to e power y, and this n is a coefficient of dy. So differentiate this term partially with respect to x. So del n by del x, here when we are differentiating with respect to x partially, that time we have to keep y as a constant. So here e raised to e power y is constant, derivative of x is 1 plus 2y. Y is a constant, so derivative of complete constant term is 0. Now see here, the both derivative of m and n are equal, so del m by del y is equals to del n by del x, and if this condition is hold, so we can say our given differential equation is exact. So therefore equation 1 is an exact differential equation. Given differential equation is exact, so therefore the general solution of exact differential equation is integration of m dx keeping y as a constant plus integration of n, from n we have to take without contain x term, is equals to integrating constant c. So here integration of, as per our question, our m is e raised to e power y. So here m, put the value of m, it is a e raised to e power y dx. We have to take y constant plus integration of n without contain x term. So here n is x e raised to e power y plus 2y. So first term containing x, so we have to skip this term and take n equals to simply 2y. So from n we have to take the term which does not contain x, so it is a 2y dy equals to c. Integration of this term, we are taking y constant, so here e raised to e power y is constant term outside. Integration of dx is x plus 2 as it is, integration of y is y square by 2 plus is equals to integrating constant c. Now here this 2 get cancelled, so final solution is e raised to e power y into x plus y square equals to c. So this is the general solution of our given differential equation. Now see the next example. So therefore, a given differential equation is minus 1 upon y sine x by y dx plus x upon y square into sine x by y dy equals to 0. Compare this differential equation with mdx plus ndy equals to 0. So m is a coefficient of dx, that means m is equals to, we get minus 1 by y sine x by y, and n is equals to x upon y square sine x by y. In the next step, we have to check whether our given differential equation is exact and or not. So for that, we have to differentiate this m and n partially. So I will write this m in the next page. Our given m is minus 1 by y sine x by y, and m is a coefficient of dx, so we have to differentiate this equation partially with respect to y. To use the product rule for differentiation, so del m by del y is equals to, apply the product rule. Here the first term is as it is, minus 1 by y as it is, derivative of sine is cos x by y, again derivative of angle term, because angle is again a function, so angle term x as it is, derivative of 1 upon y is minus 1 by y square plus second term as it is, sine x by y as it is derivative of first term. So first term is minus 1 by y and 1 upon derivative is minus 1 by y square. So it is a 1 upon y square. That means here I use the formula of product rule u into v, that is u as it is derivative of v plus v as it is derivative of u, and here sine is a function and its derivative is cos, and angle is again a function, so derivative of angle term. When we are differentiating with respect to y partially, that time x is constant, so x as it is derivative of 1 upon y, so derivative of 1 upon y is minus 1 by y square. So that's why we get here minus 1 by y square plus second term sine term as it is, or 1 upon y derivative is minus 1 by y square, and this already minus is there, that's why we get here plus. Now simplify this term, so it is a this minus into minus, here first term contain 2 minus, so product is plus x upon y cube cos x by y plus 1 upon y square sine x by y. So this is a del m by del y term. Now similar way we have to differentiate n partially with respect to x. But given n is x upon y square sine x by y. This n we have to differentiate partially with respect to x. So del n by del x is equals to first term keep as it is, derivative of second term, sine derivative is cos x by y, again derivative of angle term. So angle term is x by y, and if we differentiate this term partially with respect to x, so that time constant 1 upon y we have to keep as it is, and derivative of x with respect to x is 1. So and derivative of angle term is 1 upon y. So first term as it is, derivative of second term, so sine derivative is cos, and again derivative of angle term, so it is a 1 upon y plus second term as it is, sine x by y as it is, derivative of first term. In a first term 1 upon y square is constant and derivative of x is 1. So numerator term derivative of x is 1. So therefore del n by del x is equals to this 1 upon y into y square is x upon y cube cos x by y plus 1 upon y square sine x by y. Now compare this. So here this is our equation number b, and derivative of m partially with respect to y, that is our equation number a. So see here equation A is x by y cube cos x by y plus 1 upon y square sine x by y, and same we get the equation number b. So right hand side of equation a and b is equal, so from equation a and b del m by del y is equals to del n by del x, and this imply given differential equation, so this imply given differential equation, given differential equation is exact. Given differential equation is exact, so hence its general solution, general solution is integrate m with respect to x keeping y as a constant plus integration of n dy. Here we have to take the terms of n not containing x. So from n we have to take the terms which does not contain x, not containing x is equals to c, where m is minus 1 upon y sine x by y dx. Here we have to take y constant plus integration of n without containing x term. So see here our n is this one, and it contain only one term and term containing x. That means without x term is not contained in n. So here this is 0 y equals to c. So there is a no term in n containing without x. So if there is a no term without x, so we have to keep we have to take 0. Now here integrate this term. Our y is constant, so minus 1 upon y we have to take outside. Integration of sign is minus cos x by y, and here variable is x. So with variable there is a constant 1 upon y, so that constant we have to divide. So 1 upon y is equals to c. So 1 upon y get cancelled and this minus of minus plus, that means final answer is cos x by y equals to c. So this is the solution of our given differential equation. To solve this integration, I have used the formula, that is a integration of sine ax dx is equals to minus cos ax upon a. So using this formula, we will get this integration. Minus 1 upon y is constant, we have to keep outside. And integration of sine is minus cos x by y. And with x, if there is any multiplication term, that is, we have to take that term is a constant. So here y is constant, so 1 upon y is constant. And that constant we have to divide by this integral formula. So integration of sine is cos x by y and divided by 1 upon y equals to c. So numerator denominator both contain 1 upon y. That 1 upon y it cancel. This minus of minus plus. So final answer is cos x by y equals to c. If you have any question related to exact differential equation, then you can put that question in our Telegram group or in chat box. Thank you.